Let's solve this problem together, or two city scheduling. Let's understand the problem first. The company is planning to interview 2 young people. Given the array costs, where cost I is the first element of the array is cost to fly one person to one city versus to another city. So the cost of flying ith person to city A is A cost I, and cost to fly ith person to B is B cost I. Return the minimum cost to fly every person to a city such that exactly young people arrive in each city, right? So let's say this is city A and this is city B. So some people might be living here. Let's say 1 is living here, 2 is living here, 3 is living here, 4 is living here, 5 is living here, and 6 is living here, because always there are even number of people. So for 1 to fly to A, it might cost him, let's say, $300. To fly to city B, it might cost him $600, right? For 2 also it may be similar, 150, 600. For 3 it may be opposite. For example, this one is 200, this one is 400, something like that, right? So overall the company wants to minimize its expenses, but it wants to interview young people in this office and young people in this office, right? So what is the minimum money the company can spend to achieve this, like just by deciding like which person should interview in which office? So this is the problem. How do we solve it? And we are given an array costs where the first element is the cost to fly the first person to city A and city B. Similarly, the second is the fly second person to city A and city B, and so on, right? So provided this data, we need to return the minimum cost to fly young people to city A and young people to city B. So thinking about it, so I mean, we might think about, let's say we want to sort this array by the first person, right? Let's say 10, 20, 30, 200, 30, 20, and 450. So if we do a sorting like this, and then for the first n we will choose the first, and the second n we will choose this, might work, it might not work, right? Because this case the actual answer is in the example is 110, whereas we'll get 40 plus 50, 70. So this case it works. But what if this 30 and this 30 are interchanged, and we add this 30 and 10 because it has the same value, and then we add this, right? So we might say if it is equal, we might want to see the next value also to do the calculation. But I think this is not the optimal way of solving this problem, because there might be a scenario where, let's say second example, 10, 20, 20, 50, 30, 300, 40, 400, right? What if this is the example where if we choose the first minimum values of these two elements, we might have to pay a lot more extra for these two, right? So in this case our answer will be 400, 300, 700, 30, but we can do it much less if we choose these. If we send these two people to city A and these two people to city B, we can do it in 70 plus 70, 140, right? So 140 is way less than 730, right? So sorting definitely will not work in this scenario. What is the alternative? So we can sort with the second city and choose n people from there, and then the remaining one we can choose n, but it will have the same problem, right? So the way to solve this is we want to minimize the overall expenditure of the company, not just the group that we are sending to group city A, or not just the group we are sending to city B, right? So the overall expenditure, how do we minimize? If we take the difference of these elements into account. So let's say I will see the difference is 10 minus 20 is minus 10, 20 minus 50 is minus 30, 30 minus 300 is minus 270, and 40 minus 400 is minus 360, right? So in this scenario, the higher the value means more reason to choose B. The lower the value means more reason to choose A, more reason to send this person to A, right? So if we sort by this value, so we'll get minus 360, minus 270, minus 30, and minus 10. This means the first n person we can send to city A, and then the remaining we can send to city B. So we are minimizing the difference. So that means this will be the optimal solution for this. So let's just see that in action. So as we described in the previous sketch, we are creating a class called benefit, where A is the first price, thus P is the price to send to the second city, and benefit is the difference of A and B. That means the higher the benefit means more reason to send B to the city rather than A, because A minus B is higher means the cost is higher to send to the city A. That means pick B, right? And then we have a priority queue where we are sorting, and then we are returning the descending order of the benefit. That means first choose B, and once you have chosen NB n people to send to B city, then the remaining one we can choose the A city, and that's how we calculate the overall benefit, overall cost, and this works. Thank you guys. Thank you for